Hi guys, oh my goodness, I was recording and I realized that when I was recording for like 48 minutes or so, or something like that, or 30 something minutes, and I realized, unfortunately, that my mic was muted. So I am so sorry guys. But anyways, we're gonna go ahead and just move forward. I'm just gonna go ahead and explain everything that I did in that duration, in the whole video that I did before, because I really don't want to start over. So bear with me. I'm just gonna explain everything that I did in the past video that I did. So one of the main things that I did, and I did a little list first, was solving compound inequalities. So compound inequalities are very special types of inequalities. They give you something like this and you have to, they either tell you to graph it or they tell you to just solve it. Now, one of the things that, and rather, instead of what is it called, doing that, what I want to kind of go over first, really, is the idea of, what is it called? Of just solving inequalities themselves. Because the main thing is that when you solve inequalities, you have to remember the rules. Now, there is a rule that it says when you multiply or divide by a negative number, you switch the inequality symbol. That's what it says, like, right over here. And that's a very important thing to remember, because obviously if I said, negative x plus 1 is greater than or equal to, I don't know, negative 3, and then I said, oh, you subtract by 1 and you say negative x is greater than or equal to negative 4, and then I divide by negative 1, and I say x is greater than or equal to 3, or 4, no, this is not correct. It's x is less than or equal to 4, not negative 4. Sorry guys, my dog was barking. Anyways, so like I said, when you multiply or divide by a negative number, you switch the inequality symbol. So obviously if I said something like, it's gonna obviously be x is less than or equal to 4. And that's what I went over, like, in the last video. I also went over how to graph, oh, and in this part here, actually, when you talk about, like, inequalities, what you want to do, and if you have something of the form a is less than or equal to x is less than or equal to b, you always want to go from lowest to highest, right? You never want to go from a big number to a small number, because that's going to be wrong. That's why I said never do this. So, hold on. Never do this. You never, ever, 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 ever do this, right? And let me just mark it. I'm going to mark it red. You never, ever, ever do this. Ever. Because that's not right. It just wouldn't make sense. It's like if I said 5 is less than or equal to x is less than or equal to negative 1, then I graph it and I'm like, okay, I go from 5 to negative 1 and it's gonna be like, wait, what? And I'm just gonna think that it's you can get confused and you can think, oh, it's negative 1 is less than or equal to x is less than or equal to 5, but no, it's not. It's 5 is greater than or equal to x is greater than or equal to negative 1. So don't know who's calling me. Oh my god. So, in reality, you can't graph this. That's not what it would be. You never want to do this. You always want it so that from A to B, it is from lowest to highest. Always, always, always. Now, if we did have something like that, you said, oh, -1 is greater than or equal to x is greater than or equal to 2. Then it would, in reality, this, so like 5. Now, if you have like, so if you have -1 is greater than or equal to x is greater than or equal to 5, if you really did have something like that, it would be like, it would be something like this. So it'd be, so you would say -1 is greater than or equal to x, right? But then it's also greater than or equal to 5, so you're going to shade all of this, really. But I don't think they would give you something like that. Like, it's very rare that they would give you something like that on a final exam. So in reality, the whatever the, basically the real, like, if they were to say, oh, what is this in interval notation? If they have something like this, it would just be like -1 to infinity, because you're also including 5. But if they did have something like where you say -1 is greater than or equal to x is greater than 5, and like I said, I really doubt they would give you something like that, but you would say, okay, this is 5, let this be -1, and then you would say, okay, from -1 to 5, and you would say, okay, well, -1 is greater than or equal to x, right? But then it's also greater than 5. So you're in interval notation, you would be from -1 to 5 union 5 to infinity. But like I said, I really doubt they would give you something like that. Anyways, we also did graphing in standard form, which was this. And your main, what I was saying here was that your main, like, what you mainly want to do here is you either want to say, okay, if you can, go ahead and say, if x equals something, then y equals something, but you want to make sure that both your coordinates x and y are actually whole numbers, because if you make them decimals, it's going to be hard to actually do the equation, like, you know, in terms of what is it called, like, it's gonna be hard to graph the equation given decimals, because you're not gonna really, like, it's just gonna be hard to do that. So like this example here, 2x plus 3y equals 4, you know, obviously, you know, my best advice to you is, when you have one of these, is you want to say, okay, this is how it would be in slope-intercept form, right? Let me make sure it's actually... Okay, good. So it's in slope-intercept form, right? And then you ask yourself, okay, well, if x equals 0, what is y? Or if y equals 0, what is x? And then if both of those give you like a decimal, then you say, okay, well, you test another one. You say, if x equals 5, what is y? If You know, until you find a number that actually like works, or a point that actually works, you know? Because honestly, yes, it can be kind of tricky. Now if I said, um, I don't know, like, if you did something like this, or if you said, okay, well, I don't know, like it's equal to some random number like 9, then okay, like, you know, you kind of have to play around with it until you finally find, you know, two coordinates that are, or an x and a y that are whole numbers, and then you use that coordinate. So for example, here we got 2 comma 0 here. So then we use that and we say, okay, we're going to solve for y. So now our slope is negative 2/3. That's rise over run, right? So we went 1, 2, and then 1, 2, 3. 1, 2, 1, 2, 3. So that's the point of these, is that you want to find kind of like a way to say, okay, like, you know, find a coordinate that has an x that's a whole number and a y that's a whole number, right? That's your point there. And also, I did go over like inequalities here. And I don't know if I already mentioned that, but basically, when you divide or multiply by a negative number, you switch the inequality. So here I did negative 2x plus 1 is greater than or equal to 5. I said, okay, you treat that as a linear equation. You say negative 2x is greater than or equal to 4, right? And then you divide by negative 2 on both sides. Now, when you divide by negative 2, the inequality switches. So it's going to switch sides. So now it's x is less than or equal to negative 2. You have to remember that because it's so important. And I know that a lot of people who do inequalities, they forget to switch the inequality symbol. And that's why they get it wrong, because they didn't switch the inequality symbol. And this is kind of where I was gonna continue, where I said, okay, you know, y is greater than or equal to 2x plus 3. And so basically, when it's greater than or equal to, you want to do a solid line, right? That means like a whole line where it doesn't have any dashes or dots. So basically like a linear equation, right? We're going to go ahead and do, we're going to plot 0, 3. Okay guys, I'll be back. I'm going to go eat something and then I'll be back to continue recording. So give me like maybe 20 minutes or so. I'll be back. Okay, so I'm back. Let's see. So the way you're gonna do this is, you're gonna graph it just like a linear function. Let me just make sure okay. So you're gonna graph it as a linear function, right? And you're gonna say, okay, like, so basically we have 1, 2, 1, and then 1, 2, 1, right here, 1, 2, 1, and you just keep going until you graph it, right? And since it is a greater than or equal to, you're just gonna go ahead and oh gosh, let's see. You're just gonna go ahead and do that line, and then you ask yourself, okay, like, for example, let's look at the left side, right? And let's pick a point. Let's do this point here. Negative 3, 1, right? You're gonna test to see, or even 0, 5. You can do 0, 5 if you really wanted to. So this one, you're gonna see, okay, for 0, 5, so you're gonna say 5 is that greater than or equal to 2 times 0 plus 3. So you have 5 is greater than or equal to 3, and then you have, and that's true because 5 is greater than or equal to 3. So that means that this entire side, oops, this entire side is going to be shaded, okay? So you're going to go ahead and just shade this whole side here, and that's how you would do it. So, and versus if we had, you know, let's say we had something like, let's say we didn't even have greater than or equal to. Let's say we had greater than, right? 2x plus 3. You would do the same thing. You would plot the points, and then, but this time, instead of a solid line, you would do a dashed line because it's greater than, right? Or a dotted line, but I would do dashes like this, and right? And then I would shade on the left side again. So like I would shade like this on the left, but with a dashed line. You have to be careful when you're choosing your answer. You have to be careful to know, okay, is it dashed or is it solid? You know, because sometimes whenever they do the copy machine, sometimes doesn't do it right, and yeah. So like this, and then, and that would be your answer. Now, if they said y is less than 2x plus 3, so y is less than 2x plus 3, you're going to test, let's test 1 comma 1. Right? And what you're going to do is you're going to go ahead and say, okay, is 1 less than 2 times 1 plus 3? 1 is less than 2 plus 3, so 1 is less than 5, and that's true. Then you say, okay, so then you say, okay, that's true, so that's included in the sign here, or that's included in our interval. So we're gonna shade this entire part, right? And that's how you would do it. Now if they said, okay, y is greater than 2x plus 3, right? Now if we switched it, and we chose 0, 5 again, so we say 5 is greater than 2 times 0 plus 3, 5 is greater than 0 plus 3, 5 is greater than 3, so we're just going to go ahead and shade on the left because that satisfies 0, 5, right? So we shade on the left and we keep it dashed, right? And that is how you would graph a linear inequality. So now comes another part. So we're going to do systems of linear equations. Now these are I'm just going to go over this really briefly because well, yeah, I want to spend too much time. So when you have a systems of linear equations, there's 3 types. There's the first type that has no solution. That means that we have 2 lines. So we have 2 basic lines, right? And that they do not intersect, right? So let's say we had something like this, right? And we say, okay, or let's say we had 2x. Let's say 2x plus 3 equals 2x plus 9, right? So then we subtract 2x on both sides. We get 3 equals 9, which is a false solution, so therefore there's no solution, right? So then there's that one, and then there's one that has only one solution. So we have something that looks kind of like this, and this is the intersection. This is one solution, right? And then, so that's like if I had, I don't know, like negative x plus 1 equals 3, and I'm trying to think, x plus y equals 3, and then x minus 2y equals 9. So then these cancel out, and then I say, okay, y minus 2y equals negative y, and then 9 plus 3 is 12, so then y equals negative 12, and then I plug it back in. I say negative x plus negative 12 equals 3, so then I say negative x minus 12 equals 3, so then negative x equals 15, and then x equals negative 15, right? That would be, so your answer would be like negative 15, negative 12, really. That would be an example of a linear equation, or a systems of linear equations that has one solution. And then there's one that has all real solutions, so we would say that it's basically the exact same line. So this line would also be this line, and then this is all real solutions. You'd also see them write something like this, which means all real solutions. X is an element of all real numbers, or something like that. So now that we know kind of what linear equations are, and you know what systems are, or rather what linear equations are really, we want to go ahead and now say, okay, let's do systems of linear equations. There are two systems of linear equations, and let me go ahead and actually do a little exercise. So there's two methods to solve systems of equations. The first is substitution, and the second is elimination. I'm just gonna go ahead and like look for some examples to show you guys how this is done, right? So give me a second. So let's do substitution. So the first one that I want to work on is 7x minus 4y equals negative 7. And your solution is always going to be a coordinate. Then we have 5x plus y equals 22. So what you're going to do is, number one, solve for x or y. Usually you would do the easier one. So here we have we can solve for y. 5x plus y equals 22. So then we have, minus 5x on both sides. This cancels out. We have y equals 22 minus 5x. Now, you're going to plug this in to the first equation, which is 7x minus 4y equals negative 7, right? So we have 7x minus 4 times the quantity 22 minus 5x equals negative 7. So then you do distributive property, you treat it like a linear equation, and you get 7x minus, it would be 88, and then plus 20x equals negative 7. So then you would say 27x minus 88 equals negative 7. And then you go ahead and add 88 on both sides. You get 27x equals 81, right? Then you divide by 27 on both sides, you get x equals 3. So now you go ahead and look at your other equation. You have y equals 22 minus 5x, and you have x equals 3. So you're going to say y equals 22 minus 5 times 3. So then it's going to be y equals 22 minus 15. And then you subtract that out. And then you get that y equals 7. So in reality, your solution would be a coordinate. It would be 3, 7. That is by substitution. So we're gonna do another one by substitution. Let's see. Hold on, guys. Hold on. I'm looking. So this is by substitution. I know it looks like we could do it by elimination, but we're gonna do by substitution. So here we have 4x minus 2y equals 8. So what number 1? Solve 4x minus 2y equals 8 for, we're going to say for x, right? So then we have plus 2y on both sides. You want to get x by itself, you have 4x equals 2y plus 8. So I'm going to divide by 4 on both sides. You get x equals y over 2 plus 2. And then you have, so then once you do this, go ahead and plug this in for your second equation. So for this one, you're going to say 2 times y over 2 plus 2 plus 2y equals 4, right? So then you do distributive property, you get y plus 4 plus 2y equals 4, and then you have 4 plus 3y equals 4. So then you subtract 4 on both sides, you get 3y equals 0, and then you divide both sides by 3, you get y equals 0, right? And now since we have x by itself, we get x equals, and then we're just going to plug in y, 0 over 2 plus 2, and then we have x equals 0 plus 2. So then x equals 2, right? So that our solution in a coordinate would be 2, 0, right? If we had something like negative 2y plus 3x equals 6, and 2y minus 3x equals negative 6. Let's say we go ahead and just, let's go ahead and say we just add it, right? Because let's say we want to solve by elimination. So we are like, oh, okay, they cancel out. So it looks like we can solve by elimination. We get 0 equals 0. So your answer would be infinitely many solutions, right? I'm trying to think of what else. Hold on. So let's see. Let's do a little bit of a tricky one with elimination, right? 4x. So let me see, hold on. So let's solve this by elimination. We have 3x minus 2y equals 2, 5x minus 5y equals 10. Your goal here is to go ahead and make it so that one of them cancel out, right? One of either the x or the y cancels out. So we have, if we look at 3 and 5, we have 3, 6, 9, 12, 15. This one we have 5, 10, 15. They have a common factor of 15, or common multiple, right? So you can go ahead and say that this is 3 times 5 to make it 15, and then you want to do the opposite so that they cancel out. So it's going to be, what times 3 equals negative 15? It's going to be negative 5 times 3. I am so sorry, guys. Oh. So anyways, you would go ahead and, so that they can cancel out, so then you would say negative 15x plus 10y equals negative 10, and then plus 15x minus 15y equals 30. So then you do distributive property, and then you say, okay, this is negative 5y, and then this is equal to 20. So then negative 5y equals 20, you divide both sides by negative 5, you get y equals a negative 4. Now you want to go ahead and plug it in for with one of your two equations. You have 5x minus 5y equals 10, so that means that you have 5x minus 5 times negative 4 equals 10. So then you would say 5x plus 20 equals 10. You subtract both sides by 20, you get 5x equals negative 10. So then you divide both sides by 5, and you get x equals negative 2. So your solution would be negative 2 comma negative 4. Now, what we're going to do is we're going to go ahead and graph linear, or actually, yeah, graph linear inequalities. Or maybe we can do graphing linear equations. So let me just do this very quickly. So, this one, we're actually gonna solve by graphing, okay? And, so we have 2x plus y equals 3, so that means that y equals negative 2x plus 3, right? And we can color code this. We can make this like pink. And so that means that this one is going to be, so our y-intercept is 0, 3. We're going to go down 2 and right 1. So 1, 2, 1. 1, 2, 1. 1, 2, 1. 1, 2, 1. 1, 2, 1. Right? And then we graph it. We go ahead and trace the line, right? And then we do 3x plus 4y equals 2. So then if you do 3x plus 4y equals 2, you go ahead and subtract 3x on both sides, and then you have 4y equals negative 3x plus 2. So then you go ahead and divide by 4 on both sides. You get y equals negative 3x plus 12 all over 4, right? So if we were to do the y-intercept, we would get negative 3 times 0 plus 12 over 4. And then that would be 0 plus 12 over 4, so that would be 3, right? So when x equals 0, y equals 3, right? Let me go ahead and make sure that's correct. Oh, my bad. I meant 2, not 12. My bad. 2. So you would have 3x plus 2 over 4. So then you would say, okay, y equals negative 3x plus 2 all over 4. So then when y equals, so then honestly, like, the way that I would do this one, again, I would check to see, okay, what number can I multiply? So like basically I can say okay, what if I do y equals negative 3 times 1 plus 2? Well, that'll be all over 4, but then, and then that will be negative 3 plus 2 over 4. That's negative 1/4. So then I say, okay, y equals negative 3 times 2 plus 2 all over 4. That's negative 6 plus 2 all over 4. So that's negative 4, right? So, if you do, so basically if you do, so basically your point would be, it would be 2 comma negative, negative 1. So then you would say, okay, that would be 2 negative 1, right? So then you would plot it right here, and then you would say, okay, you would graph it, and you would, your slope is negative 3/4, so m is negative 3/4. So you would go down 3 and right 4. 1, 2, 3, 1, 2, 3, 4, right here. Then you would go up 3 and left 4. So 1, 2, 3, 1, 2, 3, 4. And then it's 1, 2, 3, 1, 2, 3, 4, right here. And then you would go ahead and just just trace the line, basically. So it would be something like this. And your solution, your intersection would be right here. And so the solution would be 2, negative 1. So your solution would be 2, negative 1. Okay. Let's see here. Hold on. Okay, so the last thing I'm going to go over in this video is systems of 3 equations. I'm going to do a system by substitution, and then if I still have time, I might do one by elimination, but we'll see. But I'm going to do systems of 3 equations. So systems of 3 equations. So we can go ahead and do one that is by substitution if we wanted to. So solve by substitution, right? 4x minus 3y plus z equals negative 10. 2x plus y plus 3z equals 0. Negative x plus 2y minus 5z equals 17. So solve by substitution. So you're going to go ahead and solve for z on the first one. So number 1, solve for z. You have 4x minus 3y plus z equals negative 10. So you're gonna subtract 4x on both sides, or you're gonna subtract 4x and add 3y on both sides to solve for z. You have z equals negative 4x plus 3y minus 10, right? And then you're going to plug that into equations 2 and 3. So you're going to say 2x plus y plus 3 times the quantity negative 4x And let me go ahead and just color code that. Negative 4x plus 3y minus 10. And then that'll be equal to 0. So then you would have 2x plus y minus 12x plus 9y minus 30 equals 0. And then you want to go ahead and add 30 on both sides, right? You have 2x. So you're going to combine like terms as well. 2x and negative 12x, that's negative 10x. Y and 9y, that's plus 10y equals 30. So let this be new equation 2, right? And then you're going to do it for the third part. So negative x plus 2y minus 5 times the quantity, and then you're going to do negative 4x plus 3y minus 10, right? And then you're going to do distributive property, so you have negative x plus 2y, negative 5, and you're gonna distribute your negative 5 in, so you have plus 20x minus 15y plus 50 equals 17. So then you're going to say minus 50 on both sides, negative x plus, and then you have negative x and 20x, that's 19x, 2y and negative 15y, that's minus 13y, and then 17 minus 50, that's negative 33. So let this be new equation 3. Okay. So now you want to go ahead and solve one of them. So you have a system of 2 equations. And then, so basically you have something like this. And you want to go ahead and divide both. So basically, solve one of them for x or y. So you have negative 10x plus 10y equals 30. You're going to solve it for y, right? Or you can do x. Just be careful when you do it. So you have 10y equals 10x plus 30. You divide both sides by 10, you get y equals x plus 3. And then that will be, so then you put that equation, put this equation over here, right? And then you're going to say, so you're going to say 19x minus 13 times the quantity x plus 3 equals negative 33. So then you have 19x minus 13x minus 39 equals negative 33. So then you combine like terms, you get 6x minus 39 equals negative 33. And then you have plus 39 on both sides. You get 6x equals 6. Divide by 6 on both sides, you get x equals 1. Okay, now go ahead and plug it in to any equation where you have x and y. So you can do negative 10x plus 10y equals 30. So you have negative 10 times 1 plus 10y equals 30. So then you have negative 10 plus 10y equals 30. And you want to go ahead and add 10 on both sides, right? So then you have 10y equals 40, and then you do 10y equals 40, so then you divide by 10 and you get y equals 4. And now, since you have x and y, you can solve for z by putting it back into this equation. So your z equation, so you have z equals -4, and then you're going to do your x, so you have times 1, so times 1 plus 3 times 4 minus 10, so you have z equals -4 plus 12 minus 10, z equals -4 plus, and then 12 minus 10 is 2, so z equals -2. So your solution ends up being 1. It's 1, 4, and -2. Okay, and that would be your solution. Okay, so we have like 4 more minutes before, because I don't want to make this video too long, so I'm just gonna do one by elimination, okay? Just really briefly. Let me see really quick. Okay, so we want to solve this by elimination, right? So we're gonna go ahead and so one of the things that you're gonna do first is you're gonna look at your two equations. So the first that I always go over, you want to do this, so you're gonna do equation 1, this is equation 1, this one is equation 2, and this is equation 3, right? So you want to make it so that you get equation 1 and 2, you cancel one of the variables out, and then you get equation 1 and 3 and you cancel one of the variables out, and you do the same thing until you cancel all the variables until you have one variable, and that's how it works. So let's go ahead and do this. You know, we're gonna go ahead and do it this way. So we have equation 1 and 2, we have x minus 3y plus 3z equals -4. And then we have, so equation 1 and 2, 2x plus 3y minus z equals 15. It looks like we can cancel out our y's, right? So we can cancel this out. So basically, we have these two, right? So we're going to go ahead and cancel out the y's. We have 3x minus 2, or plus 2z equals 11, right? Let this be new equation 1. So out of these two equations, we got this equation, right? Let this be new equation 1. So that means that out of this, we get 3x plus 2z equals 11. So then this would be, so then once you do this, you would go ahead and say, okay, now do equation 1 and 3. So you're going to do the top equation and this equation right here. So you're going to say x minus 3y plus 3z equals -4, and then 4x minus 3y minus z equals 19. Now you want to make it so that one of the variables cancels out. We're specifically canceling out y. So what you're going to do is you're going to go ahead and get one of them and, you know, make it so that it cancels out. So we have, this would be made into, this would then go as this. So it would be x minus 3y plus 3z equals -4, and then -4x plus 3y plus z equals negative 19. So then you would go ahead and add these, and then you would cancel the y's out. You have x minus 4x, that's negative 3x, and then 3z plus z is 4z, right? Negative 4 minus 19, that's negative 23, right? And then you grab new equation 1 and new equation 3, or new equation 2 actually, because really it's just two equations, right? So out of those two equations, you have negative 3x plus 4z equals negative 23. And then you would say, okay, now you have a systems of two equations and two unknowns, so 3x plus 2z equals 11, and negative 3x plus 4z equals negative 23, right? So then you cancel the x out, you have 6x equals, and then 23 minus 11 is 12. You divide by 6 on both sides, you get x equals 2. Now, you can grab this equation, so 3x plus 2z equals 11. You can plug this in, right, into this equation. 3 times 2 plus 2z equals 11. So you have 6 plus 2z equals 11, and then you say, okay, this would then be or actually, hold on, guys. Okay, my bad, guys. I meant, hold on. This was supposed to be, so it's 6z equals negative 12. Divided by 6 on both sides, you get z equals negative 2, right? And then you go ahead and you plug this in to this equation. So then you have negative 3x plus 4 times negative 2 equals negative 23. So then you have negative 3x minus 8 equals negative 23. You add 8 on both sides, you get negative 3x equals negative 15. Divide by negative 3, you get x equals 5, right? And lastly, to find y, you just plug it in to one of these equations. So we have x minus 3y plus 3z equals negative 4, right? So then it would be 5 minus 3y plus 3 times negative 2 equals negative 4. So then you have 5 minus 3y minus 6 equals negative 4. So then it's going to be 5 minus 6 minus 3y equals negative 4. So then you have negative 1 minus 3y equals negative 4. You add 1 to both sides. You get negative 3y equals negative 3. And then you divide by negative 3 on both sides, you get y equals 1. So your solution is 5, 1, negative 2. Okay, guys, I think I'm going to stop it right there because, like I said, I don't want to make this video too long. But if you have any questions, please let me know. If there's any requests on anything, like there's a problem that you guys have that you guys want me to do, please let me know. In the next video, we're going to start doing absolute value equations and inequalities. So stay tuned for that, and also absolute value functions. So with that being said, guys, I hope this helps, and I will see you guys in the next video. Bye, guys.